It's a gorgeous day out there today.
Yeah, this is nice. Enjoy while it lasts, though.
I know, there are two seasons here, winter and construction, right?
Tell me about it. Can someone turn the radio on? I'd like to see if the weather's gonna hold up for this weekend.
Got plans?
I don't know. But, is the weather on?
And it's another beautiful day in Chicago, currently 74 degrees with an afternoon high of 81. Winds are out of the east at 23 miles per hour, light rain expected tonight, and sunny for the weekend. We'll be back to music on WKKC right after this.
Whatever you're doing, it's gonna be nice.
Well, he said the wind was heading east, right?
I think so.
Well, that's strange.
Why?
Well, I've been watching some of these boats out here, and it looks like they're coming in.
They're allowed to do that.
Well, heading in is heading west.
So, is he always like this?
Mm-hmm.
Well, so the sailboats sail straight into the wind. How they do that?
I have no idea.
I need a scientist.
It's hiding behind guanine, cytosine and thymine. Science you find in the city. Energy's discreet on the corner, on the street. It's science you find in the city. It's oscillators, regulators, emulators, generators. Science you find in the city. It's time to explore what science is for. Out the window and beyond the door.
City Science with Mike Davis.
Professor Mike.
Yes, hello.
Hi, I'm Kevin.
Hi.
Sorry, some friends and I were in the car, and we listened to the weatherman. He said the wind was heading east.
Mm-hmm.
And there were boats in the water, and they were heading west.
Yeah.
How's that possible?
No. See, the boat is supposed to be on the inside of the bottle. It says in the instructions right here.
Well, I'm sorry, Professor Mike, but maybe you should have built it from the inside. Sorry, I was wondering if you can help me with my question.
What can I help you with?
How do boats sail into the wind?
Oh, that's a good question, the first of many. First, let's see how they float.
Wow, you got a lot of nice stuff in here.
Yeah, thanks. Now, I'd like to make a point about buoyancy. Boats do more than sail into the wind. They actually float in water.
Well, if it doesn't float, it ain't a boat.
Whatever floats your boat. See, the important parts of a boat are actually made of stuff that's quite heavy. They would sink in water.
So if the parts don't float, how does the boat?
Well, it has to do with density. You see, density is the ratio between the mass and the volume of an object. Basically, it's the amount of stuff you have in a certain amount of space.
Okay.
So water, fresh water at least, has a density of about 1 gram per milliliter. That means that every 1 gram of water occupies 1 milliliter of space, and every 1 milliliter of water weighs 1 gram.
So it's something like this piece of metal right here, which has a larger density.
Yeah. See, it sinks to the bottom because it's made of aluminum. That has a density of about 2.8 grams per milliliter, and therefore
it goes down.
That's right. But if we have something also made of aluminum, where we've built in some room for air,
it floats?
Yeah, it does. See, this is average density of the air and the aluminum. So for a boat on Lake Michigan, let's say, the whole boat, including its crew, has to have an average density of 63 pounds per cubic foot if it's going to float.
I've heard of things being buoyant. Isn't that the same thing?
Well, it's an application of the same thing. Basically, that talks about pushing water out of the way for an object.
I don't follow.
Well, let's see if we can make it more clear. Hi, guys. How are you?
Good.
Good. All right, you want to see some science stuff?
Sure. Yeah.
All right, I need to see what demonstration I want to do first, so I check my book. It's what all good scientists do.
Oh, God.
Oh, yeah. It says I'm going to do something really cool here.
Oh, God.
So, do you guys know why certain things float and certain things don't float?
Yes.
Yeah.
Yeah.
Why?
Because the mass of the water is heavier than the mass of the thing.
Mass of the water and mass of the thing? That's got a lot to do with it, okay.
If it has more or less air, then something.
Air has something to do with it too. We're going to talk about density and buoyancy. So what I have here, this is just a regular can of soda. All I'm going to do is put it here. This just has water in it. And it's going to push some of that water out of the way. Now this weighs about 390 grams. If it pushes out less than 390 grams of water, it'll sink to the bottom. It'll be non-buoyant. Look what's happening. It's going all the way down to the bottom. So a regular soda is going to sink. Now I'm going to put a diet soda in here. All right? This diet soda is going to push away a little bit more water. So what's going to end up happening is this.
It's gonna spill. Oh, because
Is it sinking or is it floating?
It's floating.
It's floating. See, this is very buoyant.
It has
This
more air in it. 'cause
doesn't
it
have
has
more air in it. What happens here is this does not have sugar in it. This does have sugar. They take up the same amount of space, but this weighs less. So when this pushes away a little more water, what ends up happening is the water holds it up. It exerts a force pushing it up. That makes it buoyant. Now, other things sink and float, and they can be kind of misleading. So for example, what if I had something really big and something really small? Like let's say a grape. Would that sink or float?
Sink.
Sink? Shall we see? Right to the bottom. All right, then something really big, like a bowling ball.
It has the whole
What do you think? Sink or float?
sink. No. Oh my god.
This guy here, it's very unusual. You wouldn't expect something as big and heavy as a bowling ball to float in water, would you?
Excuse me. How does the bowling ball float since it's heavy?
It's a good question. Why does it float when it's heavy? Bowling balls are made of something very light. All bowling balls are also about the same size. They just have different weights. So this guy right here weighs 10 pounds. When I put it in the water, it's going to want to move some water out of the way. It moves a little more than 10 pounds of water out of the way.
Because it pushes the water out of the way, and then that water becomes.
That water is able to hold it up. It exerts a force holding it up. That's what makes it buoyant. That's what makes boats float.
Bowling balls floating in water. I did not see that coming. But I get the whole concept of buoyancy now.
Oh, good. You know that boats are heavier than 10 pounds and they float in water.
Well, that's really cool. But I like to see how they move.
Ah, yes, sailing. Well, that has to do with pressure.
I've heard of that before. Isn't that like a push?
It's like that, yeah. I mean, pressure is force per unit area, and we're talking about air pressure. So this is force exerted by molecules in the air.
I did not know air exerted that much pressure.
Oh, it does. Watch. Just got a balloon here. Ready? I'm going to blow on it. It's kind of funny. Okay, this is a little flask. It's called a Florence Flask, and I have some water down at the bottom. That water's getting really, really hot. What does water turn into when it gets hot? Yeah.
Gas.
What's it turn into?
Gas.
Gas. There's a name for that gas. Starts with an S. Do you remember?
Steam.
Steam, that's right. It's turning into steam. So this steam is getting bigger and filling up this entire space, but that only happens when it's hot. So here's what I'm going to do. I'm going to put a glove on, take this off the hot plate and put it down here on the counter, and then put the balloon on top, stretching it over. What do you guys think is going to happen to the balloon? What do you think?
I think the balloons is going to get bigger because the steam is rising and trying to make.
It's a good thought. And you, what do you think?
I think it's gonna blow up.
You think it's going to blow up. Oh, that's certainly a guess, isn't it? All right, let's see. Here we go. Put it down here. See a lot of steam coming out on the top. Here's the balloon. Now we have to give this one a little bit of time. So maybe I'll hold it up so it's a little easier to see. Is it blowing up and getting bigger?
Yes.
It is? Let's see.
The water or the air is getting Oh my god! Oh, the air is sucking in because it stops it, and then God,
Look
it's
at
gonna
this.
it's gonna pop the thing. Oh God!
What's happening in here?
It's pulling it in because the balloon top stops the air from coming, so when it goes back down, it sucks it in.
So here's a very important thing to notice. What did I have in here before I put the balloon on? Was it air or was it steam? It was sitting on here, really, really hot.
Steam.
That's very good. I had a lot of steam inside here. Steam was filling up this whole space. When I took it off here, I put it down and I put a balloon on top. Steam started to get cold and shrink back into water. Air wanted to get back in the bottle, but the balloon was in the way. You see?
So the air's
this air is pushing it in. It didn't get sucked in. It's getting pushed in. All right?
And it's getting bigger.
It's getting bigger. This is an example of air pressure. Air pressure is all around us all the time. Okay? Every time you guys are outside or anywhere doing anything, 14.7 pounds per square inch of air pressure is on you all the time. So it's pushing down on you guys a lot, and you guys can go home and say, Mom and Dad, I'm under a lot of pressure.